terms of power bars and mini meals. You had guidelines you had to follow on the number of calories and carbohydrates and servings that each soldier could have. So how'd you do with that? Were you able to figure out a cost or a minimum cost or a maximum cost? It's a little bit tough to do if you're guessing and checking, but if you noticed in those little bullet points, there are words like no more than or words like at least. Those go along with the inequalities we've been using. So one way to work this problem or to find out what the minimum and maximum cost would be is something called linear programming. It has to do with the system of inequalities. So let's look at this first bullet. These are called constraints. It's kind of like guidelines or restrictions or rules that you have to follow in this situation. So the first bullet says each day a soldier can have no more than 12 total servings. Let's let X equal the number of power bars and Y equal the number of mini meals. And then we're going to write an inequality for each bullet point, each constraint, each guideline. So the first one says each day a soldier can have no more than 12 total servings. What do we do with the number of power bars and the number of mini meals to get a total? We would add those together. So X plus Y, no more than 12. So this X plus Y, can it be 13 or 14? No, because it's no more than 12. But could it be 10 or 9? So that's going to be less than or equal to. Okay, what else do we know? We know that each day a soldier must consume at least 300 grams of carbohydrates. Important for keeping their energy up. So how many grams of carbohydrates are in a power bar? So 75 for each power bar, plus 15 for each mini meal. And this has to be at least 300. So could it be 400 or 500? It could be. It has to be at least 300, so that's a greater than or equal to. The third constraint says each day a soldier must consume at least 2,015 calories. So look at your chart and let's write an inequality for calories. Each power bar has 155. Each mini meal has 310. And the number of calories has to be at least 2,015. So there's our system of inequalities that has to do with this situation, and it goes along with each guideline, each rule, or each constraint. Now, how do we solve a system of inequalities? We're going to graph it. So we can use the graph on the paper, or we can go to Desmos. I'm going to go back to Chrome. I don't know why it keeps going to Edge for me. Okay, if we go to Desmos, we want the graphing calculator. Do you remember what we learned about inequalities? When we graph these, we have a shaded part. If you have a system of inequalities, then your solution is going to be where it's shaded for all of them. So we had X plus Y is less than or equal to 12. And then we had another one. What was the one for the carbohydrates? Excuse my paper rattling there. So we would have 75X plus 15Y. Now we said at least 300 grams, so greater than or equal to 300. And then we have one more inequality that deals with the number of calories. Power bar had 155. So 155X means 155 calories for each power bar, plus 310 calories for each mini meal. And each soldier has to have at least, which means they can have more, but they can't have less, 2,015 calories. So there's our system of inequalities. Now we've graphed them. You can see that that part that's shaded that dark green, that's our what's called our feasible region. Okay. A feasible region means that's where all of our possibilities are. Okay, so any ordered pair that's in that shaded part is going to meet all those requirements for number of servings, calories, and carbohydrates. So if I had, let's say 6 power bars, because those were the X's, and 4 mini meals, that would work. If I had 8 power bars and 3 mini meals, that would work. If I had 4 power bars and 6, anything in there would work, but we're looking for the minimum and maximum. So what we're going to do is use these little corners. They're called vertices. Each corner is a vertex, the plural for more than one, vertices. We're going to use those vertices. So this one is 210. That means 2 power bars and 10 mini meals. This one right here is 3.5. Okay, I'll show you. You can do this with Desmos. You just click on that point. It'll show you that that's 210. And you can click on this one and it shows you that it is 3.5. And then you can click on this one and it shows you that that is 11.1. So we can have 2 power bars and 10 mini meals, or 3 power bars and 5 mini meals, or we can have, those are the boundaries or the vertices. So then how do I use that to find a minimum and maximum? What were the prices? Each power bar was $1.25. That first point, the one at the very top, was 210. And then we had $3.75 for each mini meal. Okay. Then we had a 3 and a 5, so 3 power bars, 5 mini meals. And then we had, what's that bottom one was 11 and 1. So we had 11 power bars and 1 mini meal. So then we have to figure out, we just do the math there and figure out the prices. And then we can use that to figure out minimum is the lowest, maximum is the highest. Now these are prices for one soldier for one day, but if we figure out that, the rest is easy. Okay, so 210 came out to $40. 3 power bars and 5 mini meals came out to $22.50. This is for one soldier for one day. 11 power bars and 1 mini meal came out to $17.50. That is one soldier for one day. So now, which one of those is minimum? $17.50, because that's the lowest. Which one is maximum? That's $40. Now, did we want for one soldier for one day? No, we wanted for 250 soldiers for 30 days. So we would take that $17.50 for minimum times 250 times 30. Okay, and that will give you your minimum. Then you would take $40, because that's the highest price one, times 250 times 30. You're going to have some really big numbers. And that would be your maximum. Okay, we don't need to do anything else with the 2250 because it's right in the middle. Okay, that is, so if you will calculate that minimum and maximum and put that on there, and I'll make that an Edpuzzle question for you. And that's what we did today, linear programming with what's the minimum and the maximum.